Hey, what's up, guys? Yeah, today, yeah, I just saw this interesting problem, like so-called equality in a Pochhammer symbol. So maybe some high school problem, some stupid like some trigonometric test will ask this kind of question. So basically, you ask what's the n product from L minus one and the one minus a to the exponential 2 pi I n divided by L. Okay, and the answer will be 1 minus a to the L. So this is our goal to prove. Okay, so let me just write down. Yeah. So I will put this video in the comparatorics so you guys can check. And I hope you guys subscribe to our channel. Okay, so we start from n equals to 1 or L minus 1, and this tell you that this is 1 minus a to L. Yeah, okay. So looks simple, right? So I mean, oh, okay. So hope it's simple, easy for you. So, you can, okay. So that's a quick proof. So quick proof is obviously that you know that okay. So let's don't do this. Let's forget about quick proof. Let's prove it one by one. Okay. So the idea is idea is what? Okay. So idea is that so we know that this, if y consider xl minus 1 equals 0, then I know that the roots of this will be x equals to exponential 2 pi I n divided by L, where n from is 1 to 2 to L minus 1. Okay, so now I can consider, let's call Ri to be exponential 2 pi I n divided by L. Okay, so we know that from Newton's equality for the polynomial, we know that if I do R1k, R2k, up to like RL minus 1k will be minus 1, right? Because why did so from k from 1, so k from 1 to 2 up to L minus 1. Okay. Right, so for for k equals 1, so obviously that for k equals 1, we get R1 plus R2, right, up to RL minus 1 plus 1 equals 0, because for n equals 0, that we get 1, right? And all roots sum should be 0. Okay. Okay, and for like, so if you go from k, that if you go to k equals to 1 to 2 to L minus 1, you simply just rotate the roots. Okay, so if you like group theory, that you can easily prove it. Okay. So since it's true, so this is true. So now we can express this. Okay, so let's do this. So I can write this as k from 1 to 0, minus 1, 1 minus a r k. Okay, now I can express this a L minus 1 minus a. So I take out L of them, which become like k from 1 L minus 1 over a minus r k. Okay. 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 So what is? Okay. So what is this? Okay. So this simply just tell you that we know that x1 is a product of sorry, x minus rk, right? So k from 0 to the L minus 1, right? So okay, so by 0 is 1. Okay, so since we have this, so we can just plug this, right? So we get a L minus 1 minus a, and then plug it, so we get 1 over a L minus 1, and divided by r 0 equals 1, so divided by 1 over a minus 1. Okay, and so oh, so what is this? So this is a L minus 1 minus a, and a 1 minus a, and 1 over a L minus 1. So a L 1 over a L minus 1, okay, 1 minus a. Okay. So yeah, so this is the first proof. And the second proof, which is most also very trivial, let's just talk about a quick proof. So quick proof is that you just see this and you stick with this and you ask. You can define a p of x to be k from 0 l minus 1 and 1 minus rkx. Okay, so if you see this, that it looks like this, right? So how what is this? Okay, so obviously that okay, so obviously that what is the root of x? So you can ask what is the root? So sorry, what is the root of p? So degree p is l. Okay, degree p is l. Sorry, x l l l. Yeah, degree p is l. And what's the roots, right? So you can see the roots. So x, the roots just be what? Just be rk, right? Because if you put, because this is just rk inverse, right? So if you right, for example, basically if you put, you can check that the roots is just rk, right? Because if you times this, you just simply rotate the roots. Okay, so this guy roots must be rk, right? So k from 0, 1 to 2 l minus 1. And this will tell you that this guy must be degree of L, right? So and the leading coefficient is 1, so this guy must be 1 minus x of L. Okay, then plot x equals to A will give you an answer. Okay, that's it. See you guys next videos.